All right, everyone. Welcome back to another episode of Bell Curve. Before we jump in, quick disclaimer. The views expressed by my co-host today are their personal views, and they do not represent the views of any organization with which the co-hosts are associated with. Nothing in the episode is construed or relied upon as financial, technical, tax, legal, or other advice. You know the deal. Now, let's jump into the episode.
Hey everyone, before we get into it today, just want to give a quick shout out to this season's sponsor, Rook. Close to $1 billion worth of MEV has been taken out of users' pockets, and that's just on Ethereum, and that number is only getting larger, unfortunately. Rook thinks that it's time for a change, and they've built a solution which is going to automatically redirect that MEV back to where it belongs, into the user's pocket. So you're going to be hearing all about them later in the show. I'm a huge fan of this team and what they're building, so stay tuned to find out more. All right, everyone, welcome back to another episode of Bell Curve. Today I'm joined by Hasu and the finale of Season 4 on MEV. This is going to be a fun one, but a little bittersweet. This has been a really fun season for me.
Yeah, the grand finale. I mean, I had so much fun. Thank you for doing this with me. Thank you for pulling me out of my podcast retirement. Yeah, it's been a lot of fun to just talk about MEV every week. Yeah.
I agree. It's been a blast. And I think this episode will serve kind of as a nice bookend, and we can revisit some of the topics that we addressed in earlier episodes. And maybe the most fitting one to start with is just latency. I would love to get your sort of closing thoughts on this. We talked about this within a couple of different contexts, both in terms of sort of geographic, like a sort of a risk vector for platforms like Ethereum. We also talked about it within the context of Rollups and Solana. So wherever you want to start first, just on the general concept of latency.
Yeah, I went into this season with latency as a big topic on my mind, and it was on my agenda to bring it up to a bunch of different people and just hear their opinions, right? Hear how they think about the topic and how they are dealing with it. And so just to summarize, I guess, for our listeners, so systems that have very low latency, in like some cases, they can provide a better experience for users. For example, users get faster confirmations, but also market makers can update their bits faster so that they can kind of reflect the real cost of liquidity in the outside world. But low latency has this like really pernicious like downside, which is that it basically leads to a lot of geographical centralization. Because in a latency system, you're always incentivized to co-locate or up to the point of like direct vertical integration with whoever has the ordering monopoly on their chain. And so it leads to kind of different validators co-locating with each other, but also searchers and big block builders co-locating with validators. And in a system that is supposed to be decentralized and kind of robust to any particular regime of regulation, that's sort of almost a death blow, I would say. So we talked about this with a few different folks throughout the episode, but I think my view kind of has not changed from kind of this new information, that I think you cannot build a system that is both kind of globally decentralized and a very low latency.
So I sort of think about, maybe we could divide this discussion into sort of two. The way I think about the latency pressures is in sort of two buckets. One mental framework that I think you gave me at the start of this season was, you can think of the pressure to basically elongate time around blocks, right? The more time you have to view different opportunities, the more transactions you can see and the more profit that you can generate. So you're starting to see that play out in a super interesting way, or especially around kind of optimistic relays, which is a pretty cool example of that. And then the other type of latency is more driven by user preferences for fast confirmations. So maybe we could start with the first part of that, because then we'll get to sort of the roll-up angle in that second part. But we sort of talked about optimistic relays. He didn't use that word with Justin Drake in the episode with him and Tarun. And then we kind of continued a little bit with your discussion with Matt Cutler about like infrastructure and how we should incentivize that. So what do you kind of think about that pressure for latency? Like, how harmful is that? Is it totally fine. And then maybe if you could like sort of dredge up the debate that you had with Matt and any thoughts there.
Yeah, so something that we see in the MEV boost market is that latency is becoming kind of a very important factor in who wins blocks and who doesn't. And so we see that both with the builders. So, for example, it turns out that almost all of the winning bids are basically coming in right before the end of the bidding period. Why? Because that's the point when builders have kind of the most amount of information about the state of the world. They have also the most amount of transactions accumulated, and they have also the least amount of risk, kind of in terms of the price changing against them. And so it matters a lot that you're very well connected to the network and very well connected to the relays. Just a quick kind of shout out to our episode on searchers. So I think what they showed us is like latency is important in terms of like getting your blocks and your trades to the network, but it's also equally important on the other end, which is initially like ingesting information from the world into your search algorithm. And yeah, I think they were alluding to the fact that even more edge is basically in having like really fast and comprehensive kind of data ingestion, really good pricing models, and like basically having like a perfect view of the world around you. And that's even more important. So one innovation that you mentioned, Mike, is the optimistic relay. So it turns out that one of the roles of relays is basically be this counterparty bit, or this intermediate between the validator and the builder. And kind of the goal here is that the block builder can just send an invalid block or a block that lies about the amount of its payment to the validator and kind of steals money from the validator that way. And so originally the idea was that the relay just executes the block and just checks if these things are true, if it's valid, and if it pays the correct amount. But there are also other ways that you can do this that don't require you to actually execute the block, which takes around like between 100 and 200 milliseconds. So we call that optimistic relaying, where the block builder actually makes a deposit. So they deposit some ether with the relay, and then they can basically pass through the relay without being executed. And if it turns out that they lied about their block, the block was invalid, for example, then the relay can just take their security deposit and give it to the validator who lost money. So I would say this is overall kind of a welcome proposal. I think always like when latency becomes more important, then the decentralized market kind of needs to catch up, and then we need to make sure that kind of the decentralized thing that's available has to be like not that much worse than kind of what a relay and a builder could do if they were vertically integrated, for example, with each other. And so I don't think there's really like a way around optimistic relaying, but it does have some implications basically on barriers to entry to the relay market, but especially to the builder market, because relays now are in charge of taking deposits and like custodying these deposits, and builders also may need to put up deposits with multiple relays. Plus, there's kind of the thing where if like the value of the block gets too high, then basically it can still be profitable to steal for the block builder. Right? We've seen blocks that are 10, 20, 50, even 100 ETH. These happen sometimes, and if you want to make a deposit that kind of exceeds that, then it becomes very capital inefficient. If you don't, then basically in many cases, kind of the like size of the bond is not enough to actually secure that. And so you may need a kind of a dual approach, right? So you basically get passed through for smaller blocks that are below the deposit limit, and you have to simulate for blocks that are kind of above the deposit limit.
So, what you're describing, I'm sort of reminded of the concept of MEV burn there, with just in terms of incentives. We again talked about that on the Justin Drake episode, but I'd be curious, what you sort of thought about that. Maybe if you could rehash some of the benefits. The thing that reminded me that you just mentioned was basically, the 32 ETH is not super effective collateral if the value that you could extract from a block is much higher than that, right?
Yes.
And so I would love to get your thoughts on MEV burn, because that's sort of, it was talked about. I feel like it's gained steam even since we started doing this season. So I'd be curious to get your thoughts there.
Yeah, so we brought this up in the context of this equivocation attack on MEV Boost that happened, I think 1 or 2 months ago, where a validator basically equivocated and stole. They basically stole MEV from a block builder, right? And so why is this important? So yeah, MEV Boost basically had this assumption that the validator cannot just make a block of their own and kind of race with the block that the relay publishes. But yeah, it turned out it was not correctly implemented. And so yeah, it's basically it was true at the time that the proposer is basically can only be slashed for a relatively small amount, and so if they can steal more money, then they definitely have an incentive to do that, because they may steal more money than they get slashed for. And Ethereum's staking system is very forgiving, basically, of equivocation. So how much you get slashed for is a function of how many proposers equivocate, I believe, at the same time. And so I think this is in order to kind of protect solo stakers from the hardware having a fault, etc. And so basically, if you if you're the only person equivocating, then you get slashed for almost nothing. I think the party that ended up stealing $20 million from different sandwich bots, they got slashed for 1 ETH. So and it turns out that there is a fix that is very, very robust to kind of anything that a proposer can do. So basically it completely secures kind of the MEV Boost implementation, and that requires kind of moving from a one step to a 2-step fork choice rule. So you would first have a phase where, let's say, the proposer committee assigns basically a block header, and then the proposer assigns it or something. I forgot the exact thing, but the idea is that basically the proposer commitment becomes more credible. So it's not even possible for them kind of to equivocate in that sense. And so and ironically, this is the same thing that you need for MEV burning. Because for MEV burn, you basically need an MEV oracle. So you need to know how much MEV is actually in the block. Because if, for example, the block builder or the proposer just was able to say, oh yeah, this is how much MEV is in the block, then they would both be incentivized to just lie and understate the amount so they can kind of keep the rest for themselves. And so you need what we call a disinterested party, a party who's not the active proposer or the active block builder, and that's when you would usually rely on kind of this proposer committee. And I think kind of the solution that of burning MEV actually has a lot of parallels to how we would harden kind of PBS. And nonetheless, I think it's I used to be kind of a little bit of a critic maybe of MEV burning, but I think if it's implemented well, then I think it's a really good idea, because it just it kind of removes this instability in the block reward that can lead to kind of incentives for equivocation or for kind of reorganization attacks, stealing MEV from another validator. So optimally, in a perfect world, we would just have kind of our rewards for validators be very consistent. And I think this is pretty much what MEV burn affords us. And also, in terms of the economics of Ethereum, we don't want to overpay for security, right? So if we think that there is a minimum amount of security that we need to pay for the system to be secure, then any money that we overpay over that amount is basically, it has an opportunity cost, right? It's money that's lost from the system. And so I'm with Justin there. I think MEV burn is great. We just got to be kind of careful about how we implement it so it doesn't create any new trust assumptions in the system.
Yeah, I like that. That was a great explanation. And I think it's a good reminder that, oftentimes you see anything related to the burn and Ethereum is kind of that ultrasound money sort of graphic of the supply going down. But really, there's so much more that goes into these decisions. And often it's about eliminating threat vectors for the security of Ethereum, the network. So it's just a good reminder that that's really why a lot of these decisions end up getting made, and less about sort of the deflationary meme that you might see on Twitter. I'd love to sort of just return to that latency here and just talk about the second bucket. And maybe this will sort of bring us into the MEV and the modular stack episode that we had with John and Robert, which I thought was one of my favorite episodes of the season. It was just a great discussion. But one of the, especially within the context of something like a centralized sequencer, which is how all these rollups are running today, the incentive there, first of all, just decentralizing the sequencer set is a tricky problem, which we can get into as well. And I would love to get your thoughts. But also because users want fast commitments, right? That's a user preference, and that does incentivize sort of a lower latency sort of environment. So, you kind of started this episode by saying, hey, there's a lot of risks associated with low latency blockchains, but it seems like based on user preference that that's the way we're trending with rollups. So I'd love to get your thoughts there and how you see that playing out.
Yeah, so the main risk I see is that all of the rollups have like 1 or 2 second block times, and so we kind of it's like very clear that like as a user you want like faster and faster block times, and but if we go down this route, then the fastest block time is basically like using a centralized database. It's like interacting with the server who can just react instantly. And there's no need to like run a consensus on anything. And if we like only follow the user preference, then we basically just end up back in kind of this like very centralized Web 2 world. And the problem here is that rollups have kind of gotten the users used to this like very good user experience, but now that it turns out that we actually need to decentralize our sequencers, it's not that easy to do once you have kind of locked into this low block time, because it's relatively tricky to run have kind of proposer builder separation with 1 second block times, because this is a very short amount of time in order to kind of build a block and run like a block builder auction, especially if you want it to happen in a kind of like geographically like diverse regime, right? So Bitcoin blocks were originally like set 10 minutes apart from each other, so there's enough time to propagate large blocks between like China and Russia and the US and so on. And now we are down to like 1 second block times, and it's becoming more and more important for these parties to be like very closely connected with each other. And I think it's very likely, especially as MEV plays a big role for the returns of searchers and builders and the validators, then you basically end up in that world that we don't want, which is kind of geographical centralization.
I mean, this has been, discussed since I've been in crypto, which is basically there are different trade-offs, right? And eventually you're going to have to find some line that we're all comfortable operating in. And I'm not sure what solution there is other than to just see how it all plays out, but it's definitely a concern worth highlighting. I'd love to get your thoughts. Again, we talked about this a little in this episode we sort of highlighted the difference in between decentralizing sequencers, but each of those sequencers sort of rolls up within the same blockchain or rollup. But then there's also this idea of shared sequencer sets, right? Where you sort of have this set of sequencers that sequences transactions for multiple different rollups. And I guess there's some interest there because in theory, this could lead to more cross-domain, sort of cross-chain MEV, which has been a meme for a while. It exists today largely in sex to dex arbitrage, but in this instance, you could imagine, like a Uniswap deployment on Arbitrum and a Curve deployment on, Optimism being arbed away, and it widens up the design space and is good for interoperability. But there's a lot of problems with that as well. So maybe if you could just comment a little bit on the talk about shared sequencers and how you think about the challenge there and just where you see that whole space going.
Yeah, so my view on this generally is that the name shared sequencer is a little bit maybe of a misnomer, because it implies that the sequencer actually has kind of an opinion about the ordering, that it orders transactions in a kind of optimal way, which is not the case. So when we talk about these shared sequencers, then it basically means that two rollups or more outsource the proposing of the next block to the data availability layer to the same party. And that party can be kind of the validator of another blockchain. And so this actually includes kind of both base rollups, but also other forms of rollups. So Ethereum, for example, could be the shared sequencer for other rollups, and then would kind of be the next Ethereum proposer who also proposes the blocks for rollups. But it could also be a party like Espresso or Astria or Radius or Suave, for example, right? So if you kind of zoom out far enough, but what they all say is basically that they don't execute the block. They just take the transactions and include them. And if you do that, then of course there's like no such notion of, for example, like cross-domain atomicity, which they advertise. So James Prestwich had, I thought, a really good article on this. I think it was something in the title around like shared sequencers or sequencers, but the main idea was that a shared sequencer basically can't guarantee atomic execution. They can at most guarantee you atomic inclusion. And the reason for that is that you basically need to execute the transactions in order to see kind of how they interact with each other. Because transactions are in many ways conflicting with each other, contingent on each other. And so if another transaction is sequenced before you, then your transaction that might be like buying something on Uniswap and selling it on Arbitrum is no longer guaranteed even to succeed, because you can never know what the state you can never know what the state of the blockchain is going to be at the point when you actually put the transaction in the block, unless you put it at the very top of the block, because there's always like transactions coming before you that actually change the state, and then the transaction that you thought will succeed will actually fail. Or not succeed in kind of the way that you think it would. So it's a little bit of an arcane point, but it's very important, and I would encourage people to check out the article. So I think the way that it's most likely going to play out is that these shared sequencers will all adopt some form of proposer-builder separation, because although they all say like we don't execute the block, the service is completely useless if nobody executes the block. And so if they don't want to execute the block themselves, then they need to separate this out into a builder market. And then you just have big block builders to execute everything and kind of come up with an optimal ordering. And then the builders can basically give like they can give you almost like soft guarantees about kind of atomic execution. But you should kind of be aware that this is a trusted guarantee. So they can put your transaction. So why do I say this is like a trusted guarantee? Because the block builder can basically, like, you can't guarantee, like you cannot like cryptographically enforce that the block builder cannot put the transaction somewhere where the atomicity doesn't break. That's because they can order the transactions in any way they want, and you have no way of restraining that. And you could, for example, mandate that like block builders take a bond, for example, and then maybe the block builder can get slashed on Suave if they kind of don't respect your atomicity. But then all of a sudden, like, you get into the territory where things become very, very capital inefficient. And so it's all about trade-offs, basically. And so I would say when it comes to shared sequencers, I think it's like a nice service, but it's been overhyped because it doesn't really give you kind of the guarantees that I think people think that these shared sequencers give.
I agree with that. I think there's a lot of misunderstanding about this. And shout out to Jill Gunter, who's at Espresso. And she mentioned even the abbreviation SS that's probably not is sort of reminiscent of the sort of secret police arm of the Nazi Party, which probably for maybe multiple reasons, I agree with you. Shared proposers would be quite better.
Yeah.
But I agree. I think once you start to dig into the technical complexity of it, it's difficult. And also there's another thing that often gets cited here as well is sort of the economic incentive of the rollups themselves. So it's a very technically difficult thing to implement.
Yes.
But also in a way you could measure the MEV being generated by the centralized sequencer today as revenue for the rollups. And so there's this economic question on top of everything else that we just discussed, which is why would the protocols want to do this? So I think that's another question that and I think the general consensus is there will be some sort of revenue share, but I think that's still an open question for me as well.
You're totally right. I think the argument that, for example, as Espresso would make is that by opting into a shared sequencer, you can make more revenue for your chain than if you just like made your blocks in a kind of more siloed way. But it's very hard. So it's basically very hard to say what like a fair profit share should be between these two chains. And sequencing is pretty much the only way that like blockchains make money, right? And so it's like quite tricky to outsource that and say, oh yeah, I'm getting like exactly what I think I should be getting, because it's very hard to calculate how much each individual chain like contributed to maybe the final ordering or the final revenue of a block. So it's a very tricky problem. I think you can like solve it in a little bit of a like hand wavy way, just through maybe like governance agreements that you like adapt every now and then. But I think will be interesting to see kind of how these economics play out then in the real world.
Yeah, I'm in total agreement with you there. Maybe we can sort of segue this into the Cosmos episode that we talked about. And I'd like to get to privacy as sort of a primitive for designing blockchains, which I thought Henry did a great job of describing. But one of the analogies I'd love to get your sort of thoughts on, because I missed you during this episode, but we sort of compared the sort of internet of blockchains in Cosmos, right? It's a bunch of different sort of full stack blockchains that interact with each other. But that environment of Cosmos and the rollups, like so the sort of layer twos on Ethereum, I think there are a lot of parallels to. In that, first of all, you don't really have atomic composability like you have on main chains like ETH main chain or Solana, and you're also start to worry about standardization across different chains and how do these chains talk to each other, and maybe this idea of cross-domain MEV, which we were just describing before. How do you think of that analogy between Cosmos and sort of the roll-up environment on Ethereum?
Yeah, it's a great question. I think there's obviously, I think, a lot of overlap between Cosmos and the roll-up environment on Ethereum. I think that the line will blur more and more. I think there will be many roll-ups in the future, and you can almost like mix and match between different components that you can plug into the different layers of the blockchain, right? Different settlement layers, different data availability layers, different maybe sequencing layers, and different execution layers, different virtual machines, and like who else what will end up like stripping out, like shared mempool like Suave, I think is shared like block space auction, I think is one of the things that would make a lot of sense for many reasons. And when you kind of have the ability to unbundle a chain like that, then you gain much more control over MEV than can be afforded by a chain like Ethereum. And that's for the simple reason that Ethereum is like has a very big state. It has like a lot of applications, a lot of users that already are built on top of it, and changing anything in a way that doesn't break the system or makes it kind of breaks the social contract, at least like towards at least some of your users, is very difficult. Ethereum is also a system that's designed to be maximally credibly neutral, and so we don't want to change it too much. And that mandates that a lot of improvements to the system have to happen in a way that are kind of more backward compatible, or also more maybe don't even require changing like the core protocol, but can be built on kind of peripheral layers. So MEV Boost is a good example, right? We could have done enshrined PBS from the start, but then we would have to touch the protocol every time we need to update it. And since it's a completely new protocol that's operating in a very adversarial environment where there's too many parties incentivized to break it, we have felt the need to update it many times. And so I think the decision to keep it outside the protocol until we think we have found an iteration that's very robust and doesn't need to change also with the like changes in the market anymore. I think that decision was totally justified. In Cosmos or on kind of the more centralized rollup chains, you don't have these constraints, and so you can move much faster. You can kind of change much more things about how your blockchain works, and you don't even have this constraint of that kind of you need to kind of assume that like your validators are very like adversarial or something. Like in Ethereum, basically you have to assume, well, everybody can be a validator, and if you, for example, you can steal money from like a searcher bot, then we have no way of preventing that. Whereas in Cosmos, they can say, oh yeah, validators, like you're not allowed to sandwich a user. Why not? Otherwise we just like make a governance proposal and have people vote with their coins, and then we'll slash your coins. And so this is like very far outside what's possible in Ethereum. And I think these different constraints basically make very different approaches to MEV possible. And given these constraints, I think both like Ethereum and Cosmos are kind of doing what's right, given their unique situations.
I couldn't agree more. I really enjoyed both our Solana and Cosmos episodes. It sort of informs my general perspective that I like that there are different sort of L1 ecosystems, because I think it does encourage some amount of just diversity of thought. Maybe a slightly unpopular opinion would be, I actually don't think in all instances same think is a bad trait. For instance, in a startup, you sort of need to have same think, right? You need everyone rowing to the beat of the exact same drum that will literally be life or death. But I think once you get large enough, or once the problem and design space becomes big enough, you want to start encouraging diversity of thought and opinions. So, in general, people in Cosmos sort of think with a relatively similar attitude. Obviously, not entirely. I'm painting with a broad brush here. Same thing with Solana and same thing with Ethereum. So I thought it was super cool to, like, Cosmos is just a great example of something that's so opposite to Ethereum, because they don't have this unique problem and opportunity of securing billions and billions of dollars in TVL. They often have more app-specific chains. That's the app chain thesis of Cosmos. So they can do these decisions. And the biggest decision always for me, like the difference that they make is, instead of like trying to make validators sort of commoditized and dumb, they want their validators to do more, because they understand that consensus layer, but also the semantics of the application. And I just think there's so much cool experimentation that comes from that. So it's just interesting.
And I think Ethereum, Solana, Cosmos, I think these are the three most kind of interesting blockchains or like blockchain universes, I think, because they make very like distinct trade-offs from each other. Like they, in kind of a competitive market, we would say they are meaningfully differentiated from each other. And I think if you want crypto to win, if you're not tribal, if you just want decentralized applications to become meaningful in the world, then you should be very happy that there are different parties to explore different trade-offs and have very kind of serious communities behind them, and like attracting builders and so on their own, like in their own right. And so I definitely applaud like Ethereum, Solana, and Cosmos, or all three of them, for just like doing what they think is right and like exploring the design trade-off. And like a lot of things, sometimes they don't work and you have to like walk it back. For example, Solana going without a fee market, for example. Like some stuff may be like more obvious than others, but nonetheless, I think like what they do reveals a lot of interesting stuff. about building blockchain systems that everybody can learn from.
Quick break from the show here. I want you to imagine something for me. Imagine swapping two stablecoins on chain, paying $0 in gas, and instead getting a rebate of $2,000. This is something that's actually happened on chain. To understand how, I want to introduce and thank this season's sponsor, Rook. Zooming out for a second, the current state of affairs at MEV is billions of dollars so far have been extracted from users' pockets using MEV. Rook is coming in and saying enough is enough. Blockchain should drive value to their users and the applications they use. It is time to leave the hobbyist era behind us if we want to move forward and we want to get this right. That's why Rook has built a custom blockchain settlement network, and it's one that gives you full control over the entire transaction lifecycle. Today, you can connect to an open source Rook node. The Rook protocol will automatically match, bundle, and auction your orders and transactions in seconds with zero gas overhead. Also, any MEV that's discoverable along the way will be returned to you, the user. Created as a collaboration between the industry's top mechanism designers and MEV engineers, Rook was built from the ground up to be scalable, safe, and programmable. You can get your own mempool, choose searchers and builders, and link your mempool with others to discover even more MEV. You can define how the MEV is shared and delivered as well. And Rook can basically process anything from transactions to meta transactions and more. This is the way that blockchains basically should have been from day one. So, if you're a user listening to this, here's what I want you to do. I want you to go to your wallets, go to your favorite app, your node provider, and say, hey, I want you to be working with these guys, Rook. I want the MEV that I create to be redistributed back to me. If you're a developer and you want to stay ahead of the game, the best way to do that is to follow them on Twitter. They are at Rook. Or even better yet, slide into their DMs. They are lightning responsive. They'll get you set up today. And if you do slide into those DMs, as always, please tell them that I sent you. Now, maybe we can sort of segue into privacy here. And I would love to get your thoughts on, I thought Henry specifically had a very cool take on privacy. And, Henry sort of found his way to MEV in kind of a backwards way. He started actually as a researcher, I believe, in sort of the zero knowledge space, and was actually basically trying to find a way to give users more privacy as sort of a necessary primitive. And then that wound up having implications for MEV. So maybe if you could kind of give your take on privacy as a necessary primitive for markets functioning, as opposed to kind of this ideology, I would just love to get your thoughts on that.
Yeah, this is such an interesting topic because I would say there's three different camps in crypto when it comes to privacy that had very different motivations. So you have the very ideological people who are motivated by the idea of human rights, for example. Everybody should have the right to privacy, to transact privately, to have private thoughts, and so on. And then you have kind of the very academic camp, everybody, all of this researchers studying kind of zero knowledge and cryptography and trusted execution environments and so on. And so they are in it almost for the intellectual challenge of it, and the curiosity. And then the third camp is basically mechanism designers and market structure designers. And that includes us, I would say. And then it actually turns out that you need privacy in order to build, credible mechanisms that work. For example, auctions just tend to work, infinitely better when you can have privacy of bids, for example, right? When not every bid is kind of public and people can react to each other's bids and so on. It makes the auction extremely strategic and very centralizing as well, and also much easier to break for the auctioneer. And this is one example, but privacy is kind of extremely important when you want to build, a good market structure. And especially in the MEV supply chain, privacy is very important because there's a lot of informational value in the bids. So just seeing the intent of a person, what they want to do, basically already gives you a financial edge because you can front run them and allow you to do harm to them, basically. And it's also very important for collaboration. So one of the goals that we have for the MEV supply chain is basically for it to be very flat. Because we want validation and block production to be decentralized. We don't want any actors who kind of are able to monopolize, the MEV supply chain and accrue an extraordinary amount of power. And so we we want to, make it just as possible kind of to be a small searcher or a small block builder, and not as it is, for example, to be a bigger party. And basically what that requires is that small parties can also collaborate with each other as well as bigger parties in order to participate kind of in the same extraction process and block building process. And this collaboration doesn't work without strong privacy, because you always have to be very aware that others can steal your bundles and kind of steal money from you. And so it turns out that privacy is just of fundamental importance for the MEV supply chain. And we couldn't kind of achieve our goals if we don't solve the privacy puzzle.
Yeah. And MEV Share, which went live relatively recently, I think is a super cool example of that as well, as something that wouldn't be possible without the power of privacy.
Yeah, it's so MEV Share is a new order flow auction that differs kind of from all existing products in the sense that searchers can basically run on encrypted user orders. So searchers submit their backruns without actually seeing all of the information about the user order. So right now we reveal some amount of information, not enough to front run, but just enough kind of to constrain the search space, so that searchers are not completely blind. And then there's actually the block builders are in charge of running this simulation and matching the orders together, which is very cool. And for searchers, it's a completely new paradigm. Kind of searching on private data is not what they are used to, but we think it yields fundamentally better outcomes for users. And if you kind of continue this line of thought, then the next step here is kind of searchers searching on searcher orders, not just on user orders. So, for example, one searcher could, do an arbitrage, and another searcher could kind of, do another part of the arbitrage that maybe the first searcher was not willing to take because of risk limits, or because they had a different ability to hedge, or searchers kind of backrunning each other, or matching complementary trades together. And I think we're looking at ways that kind of order flow can be aggregated in a trustless way that doesn't require trust from anyone, and also kind of removes trust in the auctioneer itself. And I think that's kind of the next big item on our agenda.
Yes. Yeah. I want to get into order flow auctions because that was a great episode that we did with Quintus and Barnaby.
Yeah.
But before we do, I have one question for you, because I actually thought it was a telling moment in the series, I think, when it was the searcher episode and you asked both Dean and Anish, are you using private order flow? And there was probably a 5-second pause. And Anish, very diplomatically said, I think you'd be hard pressed to find any. And one sort of, trend that it is, privacy sort of is definitely this good market primitive. I'm also, to be honest, to just be transparent, I'm ideologically in the camp of privacy. I sort of find myself rooting for more privacy. I think it is a good human right that we could all probably get behind. But the sort of flip side of that is, people talk a lot about kind of private order flow, and there's so much incentive for especially builders, right, to get this private order flow. And on top of that, it does seem like there's kind of this, maybe call it fragmentation of the mempool, so to speak. And used to be there was one sort of mempool. Doesn't exactly work like that, but it was one public mempool. Now you actually have protocol level changes like count abstraction 4337, where there's this user op sort of mempool, and there's a whole bunch of different things out there. So I would love to just get your thoughts on kind of private order flow, and is that the destiny and sort of the way that MEV and transactions on Ethereum are moving, or what are your thoughts there?
Yeah, that is a great question. I think right now the meta game is definitely that it's all about exclusive order flow. So in order to so all of the top block builders are also searchers, and the way that they can basically be block builders is from their own exclusive order flow, from their searcher operations that they may not necessarily share kind of with other block builders. And because they don't submit to other block builders, but rather do the block building themselves, on many blocks, it's actually more profitable for them to do that, because if you share your if you kind of share your order flow with all of the other block builders, then kind of in a very naive example, you just increase kind of the bid of all block builders equally. Whereas that they end up paying to the validator. Whereas if you keep it private, then your own bid stays the same, but the bid of all other block builders goes down. And so you actually have to bid less. You only have to bid the second bid, right? The bid of the next best block builder. And so you just end up leaking less money to the validator and then end up retaining more for yourself. And so I think this is a strong incentive to attain exclusive order flow, whether it's from users, for example, by buying order flow from like a wallet or an application in the form of like vertical integration or striking any kind of private agreements. Or the other alternative is, of course, like running your own trading operation, because then you almost have like homemade exclusive order flow that is in many cases very, very valuable because of the high amounts of fees that it's able to pay because of the profitability. I think in order to kind of break up the current metagame of the searcher builder, so if this was allowed to continue, then you're basically going straight for that future where only the biggest trading firms are able to build blocks on Ethereum. And today that's maybe like a Wintermute, maybe an SCP. And these are like firms where you kind of know that they are ideologically aligned with crypto to a good degree. But like when it comes to, I don't know, like a Citadel or like a Tower or Virtue, whatever, like once it becomes profitable enough, then you can be sure that like the existing like TradFi HFT firms will also crowd into the space, and they have more, they have even like better people, and they have even like lower latency and proprietary algorithms and bigger balance sheets. And then all of a sudden, then you find yourself with like these new overlords that you didn't ask for, and you don't know how to get rid of them anymore. And so that's why I think it's very important to break up the current metagame and make it so that searchers can be searchers again, and don't have to kind of opine on, the composition of the entire block. And that basically requires, a metagame where order flow can be shared more freely, both because it's kind of unshackled from the bounds of trust. So you don't have to trust that anyone would steal or mess with your order flow anymore, but also kind of make it economically feasible for order flow to be shared, right? So removing this incentive that you have to pay the second bit.
So I want to get into order flow auctions. It's funny. This is one of those seasons where we could have done, I think, twice the number of episodes and it wouldn't have felt packed at all. Like there was so much we could have talked about. And I do wish we could have gotten into this subject a little bit more. And I actually I had my thinking changed about order flow auctions this season. And I'm sort of thinking about it differently than I was in the beginning.
How come?
And I would love to
change it.
So I went into this season thinking, and actually an early iteration of our final episode was going to be focused on wallets and the impact that wallets were going to have. And I've sort of changed my thought process there because, and actually some of this was I went back and re-listened to the Teo Leibowitz episode that you mentioned. It was I Pledge Allegiance. Shout out to Reverie. They've got a great podcast. And I hadn't really thought about that. We got into it with Quintus a little bit, but sort of general order flow auctions versus a specific order flow auction run by a DEX or something like that. And at least for me, I like to think about things in terms of like incentives, almost like if you start from this hypothetical, like how will they play out? And I probably changed my thinking in that I think the DEXs are the ones, the applications are the ones that have the user connection and the leverage much more so than the wallets, which I think Uniswap will be super interesting to see how that plays out because they sort of have both now. And it's definitely one to, same with Coinbase, by the way, definitely ones to watch. And then it will be kind of this interesting. So I think wallets are going to have much less of an influence than I originally thought. And then I think it will be this sort of interesting trade-off between generalized order flow auctions where maybe you have more information and therefore more like profits to be extracted versus a DEX exerting its own influence. And even though you have less, transactions and therefore less value that you can extract, they do have more leverage because they're the ones creating the MEV. So that's kind of how I've changed my thinking about it. I'd love to, like, I know you probably have a perspective about this, at Flashbots, but what do you think?
Yeah, it's a great question. I think or there are several parties in the supply chain who have a lot of power. I think I would not count out the wallets. I think there are a lot of users who basically would not change their wallet. And then I think the application is, I would say it's like in about like a 50-50 kind of split when it comes to like nudging the user to do different things. Because a lot of users also transact like through their wallet, right? So some people go to like the Uniswap front end and trade there. And in that case, I would agree, like Uniswap can kind of direct the transaction wherever they want. And this is actually a thing that if they were to adopt 457, then it becomes even easier to do. So it gives the application even more control over how exactly the transaction is executed. But for many users, also the wallet is simply kind of their portal to crypto, and they rely on whatever the wallet is telling them, like where to trade, for example, or even executing their trade outright, as we see with MetaMask. And so I think both have a lot of power, as does Coinbase. So Coinbase for many is even like the starting point for many in kind of their onboarding journey to crypto, because you couldn't even use like a MetaMask without first like buying some ETH. Like you need to deposit euro, need to buy some ETH, and you need to go out. And so I think they actually are all uniquely powerful in their in their way. And I think that it just differs by different users, I would say. It will be very interesting to see how that plays out.
So right now, it just really depends on how this all ends up playing out, right? So when I think about, okay, what impact or sort of leverage can wallets exert across the value chain? Well, a whole bunch of transactions flow. The intent starts at something like a MetaMask, right? And right now, if you have a solution like Flashbots or like MEV Share or something like that, or the solution that Rook has as the sponsor of this podcast, shout out Rook. You have to go. Who do you go lobby, right? You could go to the RPC endpoint. You could go to the wallet, and you're trying to. It's sort of like the marketing strategy. I would almost liken it to drug companies sort of marketing directly through like TV to the users, even though ultimately their distribution mechanism is the hospitals. So that exists today.
Yeah.
In the future, I think it's telling, actually, if you look at the Uniswap wallet, the mobile wallet that recently came out, that you actually don't have the option as a user to switch your RPC endpoint. And in the future, as we go past our little world of crypto nerds today, how many people are actually going to care about that? So in some sense, the wallets will have that. But I can't kind of help it. Also, like when I close my eyes and try to interface imagine the user interface, I think I used to think about there's going to be one wallet that wins and sort of organizes your apps, and you start with your wallet and go there. But now I kind of think that already exists, and it's called your phone. And you're going to have your phone is really going to be your wallet at the end of the day. And then you're just going to go click through apps. And then like Coinbase's wallet as a service, I think basically the apps that gain product market fit are going to integrate their own sort of wallets that'll be white labeled and sort of built into the product experience. And so I just think that, to me, it kind of comes down to the user relationship. And I think people feel more of an affinity with their apps than an interface. But
I think if you could predict who's going to own the user, then you can make a lot of money being right. I think in practice, it's very like hard to know. B, I think there will be some distribution between them, where if you look in traditional products, then it's not always kind of the user-facing product that ends up making the most money in kind of the supply chain, right? For example, I mean, there's this famous example of like Intel and Windows making kind of 95% of the profit in the PC market, even though neither of them is kind of the like makes the actual PC or like contributes any of the most of the hardware components, nor are they the party actually selling the PC, etc. And I think like how an industry is going to evolve and who ends up having power is very, very hard to know in advance, and it also differs very strongly by the user. So if you buy if you buy like an ETF, like, do you know like what's the profit split there between like I don't know, like the index provider, like how much money does like MSCI make versus like how much money does Vanguard make, or like Interactive Brokers, and how much does like Robinhood make? I mean, these are like different kind of different parts of the supply chain, speaking to different people as well. And yeah, it's I think it's like a similar situation here.
It's a very good point. Just a good reminder that's very early and it's super difficult to predict any of this stuff. Hasu, we'd love to get your thoughts, basically on sort of an app-specific order flow auction, maybe hosted by something like a Uniswap versus a more general order flow auction where you have access to a little bit more information, but you might end up sort of competing with the Uniswaps of the world in a way.
Yeah, I think it's a good question. I think Theo Leibowitz in his interview with I Pledge Allegiance, he gave some arguments for why it's better to have an app-specific order flow auction. And I think the two arguments that he gave, they come down to one, economic alignment. So he thinks that apps are not interested in sharing any revenue with a third-party provider. And the second is specialization. So he would argue that you can design an order flow auction that's much more efficient for an individual use case than a generalized order flow auction could be. I think in the other direction, you can argue also a few things. So you can argue complementarity or network effect of having more orders in the same auction. I think that's a big case for the generalized auctions, where, for example, trades that happen on Uniswap, they might have some kind of network effect with liquidations on a lending market or trades that happen on other exchanges, and so on. I think you can kind of argue that many user intents can ultimately be matched against each other or bundled together in some way. I think other network effects apply as well. So I think if you have one order flow auction, then there's only one auction kind of for searchers to adopt, because kind of the demand side from users is important, but equally important is the supply side, I would say, of like services provided by searchers and block builders. And so that's very key, I think. And then in the episode with Quintus and Barnaby, we also went into, I think, some more arguments why it can be more efficient to have a single block space auction. And I think this is the way how we are thinking about it with Suave, where there's just this one giant block space auction where like it collects all the preferences from users and then runs some kind of combinatorics on it, and kind of produces the optimal ordering across several different chains. And so we think if it's one giant auction, there's actually more benefits in terms of user surplus than if you isolated this into two steps, where first user transaction is kind of settled or auctioned off, and then there's still an auction where the searchers have to actually bid for block space with a block builder or validator. And finally, I think also decentralization is a key part. So it's much more difficult, I think, to have these like individual app mempools. So if we imagine at the extreme that every app has its own mempool, then I think this puts us much closer to a place of exclusive order flow, where exclusive order flow like dominates the MEV supply chain. Then if you had some kind of holistic solution where searchers and block builders can access user order flow, but only in a way that is in line with the user, what the user specifies their transactions are allowed to do. So yeah, for these reasons, I think that I'm betting personally that a generalized solution will be good enough, that kind of these network effects will kick in. And in terms of economics, that should then resolve itself as a result. Because if more value can be created from a generalized solution, then it would still be more profitable for an application to direct their order flow there than finding a kind of vertically integrated solution themselves.
I hear you on those arguments, and maybe it's just funny the MEV space moves so quickly. I heard you use the word intense there. That's the latest sort of buzzword of the day, and I thought it might actually be valuable if you could sort of describe what an intent is and kind of how that represents sort of a change in the way that people think about order flow today, and why are so many people focused on that particular word at the current moment?
Yeah, so intent, that word has come up in the context of basically moving to from executable transactions to more generalized intents or kind of descriptions what a transaction is supposed to do. So an example of an intent would be, rather an example of kind of an actual executable transaction would be, call this particular Uniswap pool, with this particular swap, right? So you define exactly the execution path your transaction is allowed to take. Whereas in the intent, you would only specify something very general, like I want my transaction to pay at least, at most, let's say like 1,000 USDC, and I want at least 1.1 ETH. So it's almost like a predicate on top of your transaction, what your transaction is kind of allowed to become. And then someone else can take this this sort of intent, which is not an executable transaction. It's just like almost like a small part of a transaction. And they can turn that into then an executable transaction by substituting the actual execution path. So they can find the best way to execute your trade on Ethereum or on some other domain, right? And so this gives basically more control to third parties to turn your transaction into something that can actually satisfy your intent. And if you have that, then so Kausor was the first project that pioneered this, right?
Yeah.
You basically introduce, you unbundle basically like the construction of the execution path from the user's intent. And that allows you to create competition about constructing the best execution path. So you can have multiple solvers or executors or searchers, if you will, all compete on finding the best path and then turn that intent into a transaction. And only the best one may get executed. So I think this kind of division of labor in the MEV supply chain enables much greater flexibility for the user transactions and better execution because it's basically you outsource the execution path, the finding of it, to a competitive market. So that's why I think it's very promising. But intents also carry certain risk that I feel like is worth calling out right now because it's very under discussed today. So the risk that I see is basically disrupting the MEV supply chain, especially by making fragmenting order flow a lot. So I think right now there's a vision or like a group of new parties that are positioning themselves to become bundlers because they think that they can take these user intents and generate MEV from it, or basically become new block builders on the basis of having exclusive order flow from these user intents. And I think that while chasing these UX benefits for users, we still have to keep in mind that we need to build a decentralized MEV supply chain, and that we need to and that's only possible if we actually minimize the role of exclusive order flow and seek to basically empower competition at all layers of the stack. And that involves developing solutions that make it so that user order flow can only be executed in a certain way, but also keeping it private at the same time. I think this is an interesting strategic question right now, not just for Flashbots, but for anyone, I think, in MEV. Like, what is exactly like the MEV X account abstraction going to look like? And how can these new players be integrated into the existing supply chain without kind of degrading it?
I think it's an excellent question. Maybe sort of a good place to start wrapping up, because exactly a sentiment that you just shared is maybe like a risk or a potential warning of sort of fragmenting, order flow. I kind of had the same thought about, 4337. Now we used to, returning to a simpler time, right? 2019, there's kind of one public mempool. And that was a sort of a simplistic way of viewing things. But now it's certainly more complex than that, right? So you layer in something like 4337, where you have a separate user op mempool that's sort of at an earlier stage of the chain where we're dealing with intents. And then you also might have something like a cow swap, where you can plug in to be a solver. And suddenly you have all of these different, right, sort of pools that you need to plug into. And one of my big takeaways from this season is, especially when it comes to builders, the real differentiator is just access to information, be that extending the block time through latency, be that access to exclusive bits of order flow. The more information and the more time you can give yourself, the more successful you're going to be. So my question to you is that inevitable? Because those are two trends that we kind of see accelerating, right? Like the latency sort of race and order, user information kind of fragmenting. Do you view that as inevitable? Are we relying on larger builders here? And how much of a threat is sort of bigger builder to Ethereum's decentralization and credible neutrality?
I think latency definitely plays a big role. I think the other role is just the economics of exclusive order flow. So if you're a searcher or a block builder, then by having exclusive order flow, you can just carve out a bigger pie, a bigger piece of like the MEV pie right now. So the incentives are basically in some cases like stacked against sharing order flow. And I think what is necessary is that we find ways to create the economic incentives for order flow to be like for searchers and block builders and wallets and so on, it like that they find it more profitable to share the order flow in an open way rather than sell it or keep it for themselves. And so I think this is one of the things that we're looking into. And this is one of the challenges that any kind of decentralized block builder also will need to solve. So I think both aligning the economic incentives, but also basically creating network effects from aggregating like a lot of order flow in the same place. And these problems are very closely related. So I think, yes, like size is a problem, like exclusive order flow is a problem, and latency is a problem. And it will be difficult, but not impossible to, I think, build a system, build an order flow auction, build a kind of block space auction that can address all of these.
Yeah. And, Suave, I think, plays into that. And one of the cool things for me about this season has been learning a little bit more about it. And I now, sort of describe it internally as kind of the most audacious project in crypto out of all the audacious projects that exist, because the scope of it is just so massive. And it's just so, I'm going to be very interested to see how it plays out in the coming years. But what are maybe if you could break down within Suave, what are some of the challenges that you're most sort of concerned about when it comes to Suave? And then what are some of the problems that you think are it's most immediately set up to solve?
Yeah. So maybe just to give listeners a very quick recap. So yeah, Suave is basically, we want it to be the central and unifying block space auction in crypto. So on the one end, it takes in all of these user preferences, and then it aggregates and matches them in a way and runs the auction in a way that produces some kind of ordering on the target chains. So it basically distributes the supply of block space in some way that is welfare maximizing for the users, as well as revenue maximizing for the sellers. So it kind of satisfies this dual constraint. And it achieves that basically by searchers and other parties kind of being able to upload, programs, if you will, that are, you can think of them as like allowed operations on user order flow. So the system itself is kind of this like encrypted pool of transactions, and then other parties can upload kind of actions that are allowed to run on user order flow. So MEV share, for example, is one example where if the user opts into using MEV share, then what happens is that transactions get shown to searchers in a privacy preserving way, and it allows them to recapture their own MEV. So I would say that MEV discovery, for example, is one necessary function of this auction, right? Another is maybe that transactions can get merged together, or that the user can control exactly like the execution of their transaction according to some predicates, or who's allowed to see what transaction. And that is all kind of mandated through the use of these programs. So in terms of what it most like immediately can solve, I think is just preserving the decentralization of the MEV supply chain in the light of changing kind of user preferences, but also changing kind of searcher builder strategies. So I think there's two big trends that we are seeing right now. Like on the one hand, like we see there's increasing user demand for higher efficiency in the global block space auction. And what this means, basically, users demand like lower fees, they demand discovery of the MEV, and they demand privacy from front running, right? And so if the block space auction doesn't provide these things in a decentralized way, then the users will increasingly go to centralized entities that can provide them that. And this, like, if kind of a market is contingent on trust in centralized actors, then that's very problematic, because it basically rewards the biggest and most, like the biggest and oldest and kind of most entrenched parties. So Flashbots itself, for example, can, or like a Gnosis, for example, they can provide like the service, because they are very, very old and very trusted kind of institutions in crypto. But it's impossible for like a new party to come in and say, I want to receive order flow from users, because they are less trusted. And it's very hard for them to bootstrap this amount of trust. And in terms of the like searchers and builders, I think the system needs to find a way to break basically the incentive to kind of have exclusive order flow, but also benefit from latency advantages. So it's all about kind of like arbitraging away what leads to the current dominant paradigm in order to make block building more distributed. So I think if I had to guess, then this is for me kind of the main benefit. Basically, it increases user efficiency and user guarantees in a way that also flattens the MEV supply chain and keeps it more robust. And this to me leads to much better outcomes for users, but also like in a way that preserves Ethereum's long-term decentralization. Of course, there are many risks involved with that. I think getting to a point where it's genuinely decentralized is very difficult. So right now, Flashbots, for example, is still an important kind of centralized actor in the supply chain of MEV, that many things rely on. Same goes for relays, for example. We talked about that in our episode with Matt Cutler. In terms of kind of the efficiency side of the market, I think we're very optimistic that we can, by having like an open searcher market, we can provide a better execution for users than you can have in pretty much any other system. On the searcher side, it's definitely harder, right? So if you think about what makes someone an effective searcher builder, for example, in today's metagame, then you have to like think about stuff like, like low latency access to the large exchanges, large balance sheets, like very strong pricing models, etc. And then how do you arbitrage that? Like how do you write a protocol that basically makes it so that a small searcher can do part of what currently like a big trading firm does, and that like small searchers can work together? That basically the like cross, for example, the SegStax arbitrage market becomes accessible to smaller players, and that you don't have to be a block builder in order to be effective at SegStax arbitrage. Because I think if there's like this economic like link between block building and SegStax arbitrage, that's obviously a big problem, because then over time, whatever party is the best at SegStax arbitrage will dominate block building. And so I think these are the important questions to ask. And they speak to like a lot of questions that need to be solved along the way. Mainly like latency is a big one. I think finding a way to create, decentralized privacy is another big one. But also giving orders, like arbitraging like these benefits that kind of the big centralized trading firms have. I think I would say these are definitely the challenges that we're going to face over the next year.
So maybe as a way to just bookend, this conversation and sort of the entire season, let's say it's 2 to 3 years in the future. You and I are getting together and saying, hey, it's been a little while since we did that MEV season a little while ago. Maybe we should do a rehash of that. What are we going to be talking about? Is it relatively the same subjects? Are we going to be talking about privacy and latency 2 to 3 years into the future? Is there something new? What do you think the kind of future, any trends you're particularly paying attention to, something that's under discussed now? What are we going to talk about in that season 2 years from now?
Oh, interesting. So maybe we assume that, Suave already exists and it has like a vibrant ecosystem kind of mechanisms built on top of it that like lead to MEV discovery and like different ways to execute user transactions. And it has a lot of chains connected to it as well. I hope by this point we'll be talking about how to scale the system really far, like in terms of connecting more and more domains to it, but also finding more and more network effect between different order types in order to just drive more and more value to the user, basically at a lower and lower cost. I think that would be my dream. I think it will also be a big question how the system should be governed. So my personal mental model for this is Visa, as I think I've said in the past in the season. Basically an organization that is like that like creates co-opetition from like actors that otherwise only engage in competition and kind of creates a positive externality from that. And getting the governance rights of that system right will be very important, as well as kind of decentralizing the stewardship. Because whenever you build, I think the MEV supply chain is incredibly centralizing across chains because of the network effects involved and because of the skills that you need to win on one chain's MEV supply chain are almost identical to whatever skills you need to like win on another chain's MEV supply chain, right? And in fact, being in like two supply chains makes you better in both of them, right? So that's kind of the pernicious effect of like scale economies as well as cross-domain order flow and so on. And that's why I think at that point we'll be looking at this like behemoth, basically. Like there will be no more talking about like this is like this one Cosmos chain's MEV supply chain. This is like Ethereum's MEV supply chain, and this is like Arbitrum's MEV supply chain. I think we'll be thinking about them as one MEV supply chain, and we'll be thinking about how can we harden that as much as possible? How can we make it better and better for users? How can we govern it? And how can we ensure that kind of its stewardship is, as decentralized and robust to, for example, the utility function of any individual regulator as possible? I think it'll be very much like talking about Ethereum at that point. Basically, an open source project that a lot of other applications rely on in a lot of other blockchains. Yeah, that would be my guess.
I've sort of a boring answer as well, and then maybe one that's a little bit more fun, which is I think the one that's the boring answer, but I do think would be a part of the conversation 2 years from now would be regulation. I think, especially as it gets larger and larger and more traditional firms get involved and, sort of it leaks out how much money is being extracted and the absolute value of MEV, you're going to get regulators involved there. And that's going to be more part of the conversation of, how to, what does best execution look like in a TradFi sort of world versus what we deliver in crypto. And I think that's going to be, I think Flashbots is already keyed into this with the emphasis on execution for the user, but I think that's going to be a bigger part of the conversation. The other part of the conversation, which is, again, this is it's so difficult to tease out MEV versus protocol design philosophy, but I don't know if you caught Vitalik's paper that he dropped over the weekend, and I'm blanking on the title here, but I can get it. But it's very much what Barnaby was discussing, which is where is the pomerium, right? The line of Ethereum versus, other things that are built around and outside Ethereum. And I think there will be I do think eventually people will start to look at like dApps and rollups built on Ethereum through sort of a political angle. And because that article made me think about what if, we're moving execution and users up to a big layer 2. What if there was a catastrophic, day one bug in Arbitrum or something like that, and all of that TVL just gets wiped out? That would be almost an existential moment for Ethereum because, to Vitalik's point, people would demand very loudly for there to be a fork of Ethereum's code, similarly to how there was in the DAO. And I think some of what we'll discuss in MEV is maybe like a softer, one catastrophe move in forward of that is something like Uniswap. This was sort of Dan Elitzer's point about Unichain being inevitable, where maybe some of the larger apps with PMF that are throwing off a lot of MEV will politically sort of try to, push that clout right into, favorable sort of regulatory decisions from an Ethereum standpoint. And I think that would be part of our discussion 2 years from now as well. So we'll see if that ends up playing out.
That makes total sense. I think, and regulation, I think I like the double term of the meaning. I think regulation from other blockchains, but also regulation from regulators that exist outside of blockchains. I think both will be a very important topic. The first is already a very important topic today. The second, we haven't seen much regulatory touch points basically with for the MEV supply chain. I think fortunately, because it gives us more time to preempt the need for regulation, frankly, by building systems that are better even than what can be built in TradFi. I throw in one curveball, one thing that I hope we will be talking about in 3 years, which is we'll be talking about MEV beyond crypto, in the sense that you and I, we touched on this, like the philosophical side of MEV, right? That MEV really exists everywhere. It's like in any system where there's like a privileged party that has access to information sooner, that can act on information sooner, or any situation where there's value lost to discoordination between parties. I think those all qualify as MEV according to the 3 EV model that Xinhuan San put out, and MEV is really everywhere. And I think it would be amazing if MEV doesn't stay a crypto phenomenon, basically. Like, I want MEV to become, a global field of research that basically completely changes mechanism design and like the way that we design all systems to make them more accessible and more fair and more egalitarian and just like work better for users than they do today.
I think that's a beautiful sentiment and a great place to close this episode and the season. Hasu, this has been a super fun one doing this with you. I was, saying to you offline, but this is gonna bum me out. I've really, all the seasons have been fun of this show, but I will be pretty sad to leave MEV behind. This has been a really fun one doing this with you as well. So yeah, this has been great.
Can only resonate that. It's been a lot of fun. I already feel the withdrawal kick in.